This is video 521, and the goal of this video is to find exact values using the sum and difference formulas. So the first thing what are the sum and difference formulas? They are on your formula sheet that you've received for this chapter, but what's really important is that you not think of sine and cosine as multiplication. So often we think of, sometimes students start with making the mistake of thinking that sine of u plus v would just be the sine of u plus the sine of v. This is not a true statement. Do not think that these two are equal. They are not equal. It is not distributive. That's what you're essentially doing, is distributing sine, a function, to each term. And that's not allowed. It's kind of like when you distribute squaring for something like x plus y squared. When we do x plus y squared, we don't just distribute the square, x squared and y squared. It's more complicated than that. This is also not equal to one another. So keep that in mind with these sum and difference formulas. You do not need to memorize them. You just need to be aware of them and be prepared to use them. So first, what do they do? Let's see. The first thing to notice is the way these symbols work. The plus on top corresponds to the plus on the right because they're both the symbol on top. So if we're adding angles u and v, we use the formula where we do sine of u cosine v plus cosine u sine v. And the same is true for subtracting. But notice for cosine, it kind of switches around. When we add the two angles, as you see in red on the left, we actually subtract the two values as you see on the right. And that's important. It's because the symbol on top goes with the symbol on top. And we take a look at tangent, we add the two angles, and therefore we would add the two tangents on top and actually subtract 1 minus tangent u tangent v on bottom. That's the equation for the sum of two angles inside of a tangent equation. And the opposite is true now for the subtraction. We'll use the symbols on the bottom. Subtraction of two angles, we would subtract the two tangents on top, and we would add them on bottom. 1 plus tangent u tangent v. So you'll see this in action. You'll constantly see me looking back at the formulas and thinking about which one to use. So you'll have to do that on your own when you get to your assignments. So let's take a look at this first example. How does this help us, these formulas? Well, it helps us find exact values for angles like cosine 75. That is not on our unit circle, but I can think of angles that either add up to this or subtract to get this that are on the unit circle. So I'm trying to think of two angles that add to 75 or subtract to 75 that are on the unit circle. And there's a couple of correct answers here, but the one that comes to mind real fast is that 30 plus 45 are going to add up to 75. So I can use the sum formula for cosine to find the cosine of 75 degrees exactly. So now I'm going to use the sum formula for cosine, which will add u is 30, v is 45, and I'm going to have cosine of 30, cosine 45, minus sine of 30, cosine of 45. Oh, sorry, I'm sorry, not cosine, sine of 45. So let me fix that real quick. The good news is sine and cosine are identical, so it doesn't really matter for 45 degrees. But let's do this right. Now we will actually evaluate that using my unit circle. So cosine of 30 is square root of 3 over 2, cosine of 45 is square root of 2 over 2, and so on. Sine of 30 is 1/2, sine of 45 is square root of 2 over 2. And now I simply evaluate using my fraction skills. So order of operations, multiply first. Simply multiply across the top, I get square root of 6. Across the bottom, I get 4. The second fraction, I'll get 1 times square root of 2, which is square root of 2, over 4, because 2 times 2 is 4. Last but not least, I can put these all into one fraction because they have like denominators. And I am done with that answer. That is the exact answer for the cosine of 35. Now, I could check this in my calculator, so don't be afraid to do that. I could plug in cosine of 75, and I could plug in this value and find the decimal and compare the two to see that they're actually identical. Now let's take a look at another example. Cosine of pi over 12. So now we're in radian mode. These formulas still work for radians, but we're probably not very fast with radians. So my number one recommendation is to start with changing them to degrees, because you still have to think what angles add or subtract to pi over 12. And I don't know about you, but that doesn't come real fast to me. It'll come faster to me because I'm much stronger with my fraction skills than a lot of students are. So to do it so it meets you at your level, change it to degrees. So we're going to convert it to degrees by timesing by 180 over pi. And I'm only going to humor you with this basic skill once. And I simply cancel out the pi's, and I'm going to end up getting 15 degrees. So cosine of pi over 12 is the same as cosine of 15 degrees. So I continue to think what angles add or subtract to pi over 12, or 15 degrees, and that's 45 minus 30 is 15. So I'm going to find the cosine of 15 degrees by finding the cosine of 45 minus 30 and using the difference formula. So cosine difference formula will be the cosines of the angles added to the sines of the angles. Notice the equation is addition. It's the opposite of the operation inside of cosine. So cosine 45, cosine 30, plus sine 45, sine 30. Just like the other example, I'm going to replace these with values from my unit circle. And I find the 4 values from my unit circle, and then I evaluate each of these fractions. Multiplying across the top, I get square root of 6 over 4. And square root of 2 over 4. Adding the two together, I get square root of 6 plus square root of 2 all over 4. So that is the exact value of the cosine of pi over 12. And again, I could punch that into my calculator and compare the values if I was interested in checking for equivalence. So let's do this again. We're going to find the exact value of 7 pi over 12. So again, I'm going to start with converting this to degrees by timesing by 180 over pi. And I'll end up getting 15 times 7, because remember, I knew that 15 degrees was pi over 12, and there are 7 of them. And so it ends up being 105 degrees. 105 degrees. So what two angles add to 105 or subtract to 105? And the correct answer here is 40. One of the correct answers. Okay, I haven't talked much about that, but there may be multiple ways to get this. And in this case, what comes to mind first is what you use, but 45 plus 60 equals 105. So I'm going to use that, and I'm going to use the sine addition formula. So sine of 105 will be the same as the sine of 45 plus 60. Using my addition formula means I'm going to add sine of the angle, cosine of the angle, plus cosine of the angle, sine of the angle. So it'll be sine of 45, cosine of 60, plus cosine of 45, sine of 60. Replacing these with values from my unit circle, I get square root of 2 over 2 times 1/2, plus square root of 2 over 2 times square root of 3 over 2. Simplifying this, again multiplying fractions across top and bottom, I get square root of 2 over 4 plus square root of 6 over 4, which will equal the square root of 2 plus the square root of 6 all over 4. And that is my value for the sine of 7 pi over 12. Ironically, it's the same as the other value for the pi over 12, and that is because of the supplementary angle pairs and how their sines and cosines are related. So let's take a look at one more example, but now it's actually backwards. So we notice that we have two angles that we're working with, and we are trying to find the exact values, so there must be a formula we can use here. So the first thing we notice is that we have sine of 80 cosine 20, which is very similar to the sine sum and difference formula. And the next thing that we notice is that so alpha is 80 and beta is 20. And that's the next thing we notice. And then, since the equation uses subtraction, in my equation, that means the sine has subtraction inside of the sine value. So using this formula backwards, I can replace this long expression with the sine of 80 minus 20, because it's alpha minus beta, which is the same as the sine of 60. Now that's on my unit circle. The sine of 60 is just square root of 3 over 2. And we're done with this question. We found the exact value of that subtraction problem by working backwards with our sum and difference formula. Here are your checkpoints. Your multiple choice question, yes, it's in radian mode, but it's also subtracted out, so you have two options. You can change things to degrees, make it simpler on yourself, or try and work with it as is. The free response question is just like example 4, so see if you can use that And there's the formulas there in case you don't have your formula sheet. So do your best and bring those questions into class, and we'll talk more then. Good luck and thanks for watching.